What if I told you that inside one massive factory, machines are building blades longer than a football field? Not airplanes, not rockets, but something even more powerful, designed to harness the wind itself. Each blade stretching over 100 meters, slicing through the air with unstoppable force. And yet, these giant structures begin as nothing more than raw materials, inside a billion-dollar facility, hidden behind steel walls, far from the public eye. This factory is building the future of energy. Every second, precision machines and engineers work together to create something almost impossible, because even the smallest flaw in something this massive can lead to catastrophic failure. These blades must survive extreme winds, violent storms, and decades of continuous operation, and the process to build them far more complex than you can imagine. This is not just manufacturing, this is engineering at an extreme scale. Every giant blade begins not as steel, but as lightweight composite materials. Fiberglass rolls stretch across the factory floor, long, flexible, and deceptively simple. These fibers will become the backbone of structures longer than a skyscraper is tall. Engineers carefully design every curve, every angle, every millimeter, because even a tiny miscalculation can reduce efficiency or cause failure. Advanced software simulations test how each blade will react to extreme wind forces, from gentle breezes to hurricane-level storms. Everything is calculated inside digital models. Blades bend, twist, and flex before they're ever built. Only after passing thousands of simulations does the design move forward, because once production starts, there is no room for error. Inside the factory, massive molds stretch across the floor, each one the exact shape of a turbine blade. These molds are polished to perfection, because every surface detail will transfer onto the blade. Workers begin laying down the first layer, thin sheets of fiberglass carefully placed by hand. Layer by layer, the structure starts to form, slowly building strength from the inside out. Each layer must align perfectly. Even a slight shift could weaken the entire blade. Resin is applied across the surface, soaking deep into the fibers, binding everything together. The material transforms from flexible sheets into a rigid, unified structure. Vacuum systems seal the mold, removing air and ensuring perfect bonding. Under pressure, the layers compress tightly, forming the core of the blade. At this stage, the blade is still incomplete, but its massive form is beginning to emerge. Once the layers are complete, the entire mold is sealed and prepared for curing. Heat is slowly introduced, triggering a chemical reaction inside the resin. The soft material begins to harden, transforming into a solid composite structure. Inside the mold, temperatures rise steadily, controlled with extreme precision. Too much heat, and the material weakens. Too little, and it won't fully cure. Hours pass as the blade slowly gains its final strength. Sensors constantly monitor pressure and temperature across the entire structure. Any inconsistency, even deep inside the layers, can compromise the entire blade. Finally, the curing process is complete. The mold opens, revealing the first half of a massive turbine blade. Two massive blade halves now lie side by side, each one already enormous on its own. But this is only half the story. The real structure forms when they are joined together. Workers apply industrial adhesive along the entire length, a bond stronger than steel. Precision is everything. Even a few millimeters off could weaken the blade. Slowly, carefully, cranes begin lifting one half into position. The two halves align, inch by inch, over a span longer than a football field. As they meet, the structure finally becomes whole, Pressure is applied along the seam, sealing the blade into a single solid form. Inside, internal support structures lock everything into place. Now, the full scale of the blade is revealed, a giant engineered for the sky. Now the blade enters its most critical phase, finishing and inspection. Robotic tools begin smoothing the surface, removing even the smallest imperfections. Every curve is refined, every edge shaped for perfect aerodynamic performance. Even a tiny surface flaw can create massive turbulence at high speeds. Next comes coating, layers of protective material applied across the entire blade. This coating must withstand years of wind, rain, dust, and extreme weather. Then, the testing begins. Laser scanners sweep across the blade, measuring every millimeter. Internal sensors check for hidden defects deep inside the structure, because at this scale, failure is not an option. Now comes one of the biggest challenges, moving something this massive. The finished blade, longer than a football field, must leave the factory. Specialized transport vehicles are prepared, built just for loads like this. Slowly, the blade is lifted and secured, every movement carefully controlled. The journey begins, through roads never designed for something this large. Tight turns, narrow bridges. Every obstacle becomes a challenge. Convoys move at extremely slow speeds, sometimes just a few kilometers per hour. Entire roads are cleared, traffic stopped, just to let it pass. Finally, the blade reaches its destination, a massive wind turbine site. Giant cranes prepare to lift it hundreds of feet into the air. The massive crane begins its lift, slowly raising the blade into the sky. Hundreds of feet above ground, the blade hangs in the air, perfectly balanced. Engineers guide it carefully, every movement controlled down to centimeters. At the top, the turbine hub waits, ready to receive the blade. The blade is aligned, slowly rotating into position. With precision, it locks into place, completing the turbine structure. Now fully assembled, the turbine stands tall against the horizon. Wind begins to move the blades, slowly at first, then faster. This giant structure now generates clean energy, powering thousands of homes. From raw materials to a massive force of nature, this is how the future is built.